Hi guys, welcome back. Saxon Algebra 1, 3rd edition right here. We are talking today about lesson 66. We're simplifying radical expressions and square roots of large numbers, real large numbers. Again, this lovely little cheat sheet is going to help you. So here's the top part of it. Pause that, write that down. And then here is the bottom part of that. You'll want to keep that handy. All right, guys. So let's look at our first example here. Previously, we talked about how we need to simplify these, right? So we're going to do the same thing here. We're looking for a perfect square that is hidden in there. With this one, straight off the bat, I see root 9 times root 2 plus, and in this one, I see root 4 root 2. Well, we know the square root of 9 is 3. Root 2, I can't do anything with, so I'm just going to say root 2. Plus, square root of 4 is 2. Root 2. So now what we're basically doing is combining the last 3 lessons now into one lesson because we've simplified our radicals and now we're going to add those. Remember, this is like an x and this is like an x. Those are both like terms, so we just end up with 5 root 2. As a friendly reminder, it's like 3x plus 2x would give us 5x. Because these guys match, that's like if we had x's, okay? So let's do the same thing here. We've got 8, and then I need to find a perfect square that's hidden in there, and I know we have 9 root 3, because 9 times root 3 would give me 27, minus 3, and then in 75 I've got 25. Always think if you can do quarters, then you've got your perfect square of 25, root 3. So I have 8 times, and the square root of 9 is 3, and then root 3 minus 3 times square root of 25 is 5. Can't talk today. This guy is going to be 24 root 3 minus 15 root 3. So that's going to be 9 equals 9 root 3. Excellent. Okay, so then we've got, I jumped around in this one, so I want to make sure I've got everything. Okay, yep. Okay, so yeah, this next one, same idea here with this guy. We want to find our perfect squares that are hidden in there. We just did 27 up here. You'll start to see a lot of these that they start to repeat and you just memorize them. But in the meantime, root 9, root 3, minus 3 times root, I guess I didn't need to do that little dot. It's already implied. Root 9, root 2, minus 6, and then root 9 times root 5, because 9 times 5 would give us 45, 9 times 2 would give us 18, 9 times 3 would give us 27. All right, so the square root of 9 is 3, so 3 root 3, minus 3 times square root of 9 again is 3, root 2, minus square root of 9 again is 3, so 6 root 3, root 5. Oh, oops. This is a common mistake, by the way, where if you do something out of the square root and then you bring your square root down, you got to think of your square root like an operation, and so you don't make that mistake. And now this is not 63 or 33. You got to do that multiplication there. So 3 root 3 minus 9 root 2 minus 18 root 5. All of these guys are different here, so there's nothing else I can do with this one. That is my simplified version right there. All right, so now we're going to talk about some really large square roots, and what comes in handy here is this guy. So let's leave that right there. So 10,000 is 100, the square root of 100. Or, I'm sorry, the square root of 10,000 is 100. I don't know, words are hard today. So what we do know is that we can have 10,000 here and 5, because 10,000 times 5 will give me 50,000. And we know 10,000 is, the square root of 10,000 is 100, so 100 root 5. So 50,000, the square root of 50,000 reduces down to this guy right here. Again, for this one, 100,000. So we've got 1,000. This one's going to be a little bit trickier. We know we have 10,000 here. Let's see if we can't break this down a little bit easier. Let's do 10,000, because we know that that's 100, right? So if we do 10,000, and I'm only using a calculator because you guys are costing me a lot of money because I keep making mistakes and then you keep finding them and it's late at night and I don't want to make mistakes. So making sure, okay, yeah, it's 50. I want to make sure I had that right. So square root of 50. All right, so 10,000 we know is, we can come back over here, it's 100. Root 50. Now, are we done? I bet there's still a perfect square hidden in that 50. And sure enough, think about it. If you have anything that's quarters, you got to think about that guy because it's 25 times 2. 25 times 2 would give me 50. So in this case, that becomes 5. So I have 100 times 5 times root 2, which gives me 500 root 2. 500 root 2. All right, so for this guy here, I have 40. So I'm looking at my perfect squares up here, and I could do 40 times 1 million. So that's 40. I'm going to do the million first, just to get it out of the way there. 1 million. And then I got 40 there, like that guy. All right, so 1 million we know is 1,000, so this is going to be 1,000. And then root 40, what perfect squares do we have in there? We have, let's do a little bit of side work here. We have 40, we have 4 definitely, and then we have 10, and then that's 2 and 5. The only perfect square I have in there is this 4. So, all right, we'll do root 4 and times, 2 times 5 is 10, so because 4 times 10 gives me 40. The square root of 4 is 2. So I end up with 1,000 times 2 times root 10. So that gives me 2,000 root 10 would be our simplified version of that. All right, so now we're up to 700,000. Okay, so we know that, or 700 million is what I meant to say. 1, 2, 3, 1, 2, 3, and then 7. This guy right here is going to be 10,000. Cross that out, I can do 10,000 root 7, and root 7 I can't do anything else with. So, all right guys, here are your practice problems. If you want to just go ahead and pause the video, do those, come on back, and let's see what you got. All right, let's look for a perfect square that's hidden in here. I know we have 4, but if we did, yeah, okay, so root 4 and root 6, because 6 is just 2 times 3, and there's no other perfect squares hidden in there. Plus, now we could do 4, let's do, wait. Oh, 16, yes. So I knew 4 went into this. If you know 4 does, keep trying because you want to find your largest one. So 4 does, try 16. Usually that'll help. 16 times 3. So this is going to be 2, and that's going to be 4. So 2 root 6 plus 4 root 3. I cannot combine those at all because those are 2 different ones there. All right, so 2 root 9 root 2 minus 9 root 3. That gives me 2 times 3 root 2 minus 3 root 3, because I got rid of that 9 and that one. That gives me 6 root 2 minus 3 root 3. That is as good as it gets. I should be circling these so you can see. That's as good as it gets there. Okay, on this one right here, I have 50 million. Well, I know 1 million is 1,000. So I'm going to do, let's get rid of that 1 million. 3, and then that leaves me with 50, right? Root 50. Well, we know that this has a 25 in there, so we know that this guy, I can get rid of that, and that's 1,000. And then I have root 25 times 2, because 25 times 2 would give me 50. This is 5, so 1,000 times 5, root 2, that's 5,000 root 2 would be our answer here. Excellent. All right, guys, if you have any questions, let me know. Otherwise, great work, and I will see you in class.